Okay guys, so today we're going to discuss theories and models of acids and bases. So grab a cup of coffee and let's quickly work through it a bit. So the first theory that we will be looking at is called the Arrhenius Theory. So we're going to compare the Arrhenius Theory against the Bronsted-Lowry Theory. Alright, so with the Arrhenius Theory, when an acid dissolves in water, okay, so it's all about dissolving in water, you get hydrogen or hydronium ions that are being formed. So we've talked about this. So you get hydronium ions or you get hydrogen ions that are produced in solution. When you get the dissociation of bases, so if bases dissolve, then hydroxide ions are being produced in solution, so hydroxide ions. Okay, so let's quickly look at it in an example of the ionization of acid. So let's take, for example, hydrochloric acid. If you have that, and let's say you have a gas and you pump it through water, what's going to happen is you're going to have ionization to form hydrogen ions as well as chloride ions. Okay, so essentially these hydrogen ions are now going to, in solution, react with your water to produce hydronium ions. Okay, so that's the definition in terms of acid. So it's all about the giving away or the producing of hydrogen ions. When you look at bases that dissociate, which means they break apart, and you add water to that, then it's going to break apart into ions as well. And in this case, the most important thing to note here is the fact that you produce hydroxide ions. Okay, so that's the main difference between the ionizations of acids and dissociation of bases, and how we can explain it based on the Arrhenius theory. If we compare that to the Bronsted-Lowry theory, here you need to know that an acid is a proton donor, so it donates a hydrogen ion, and a base is a proton acceptor. So this is very crucial in this theory. So for example, I'm going to take hydrochloric acid again. Remember, it ionizes, but the fact that it has a hydrogen means that it can donate a hydrogen to something else. So if the hydrochloric acid, let's say, is reacting with ammonia, then let me write that down. Let's say you have hydrochloric acid that is reacting with ammonia. Because hydrochloric acid is an acid with a proton, it can give away the proton. With ammonia, because it's a base, it would like to take up, it's a proton acceptor, so it'd like to take up another hydrogen ion to become ammonium. So when you look at the hydrochloric acid and ammonia, your hydrochloric acid is going to give away its proton, and the ammonia is going to take up that proton. So essentially you will have a chloride ion, okay, remaining, and ammonium. Okay, so this is what happened. The proton was donated, so that is an acid, and here the proton is being accepted, so that is your base. Okay, now also something about acids is the proticity. So certain acids can give away more than one proton, or one or more. So if we have monoprotic, it means that it can give away one proton. So if you look, for example, at nitric acid can give away one proton, right? And that is what will remain. If you look at a diprotic acid, di for 2 protons. So this example would be something like sulfuric acid. So with sulfuric acid, with the first protonation, it's only going to give away one at a time. Okay, so remember that this now has a neutral charge. As soon as I take away a hydrogen plus, okay, I'm taking away something positive. That's why I have a -1 charge. And what is then going to remain? The hydrogen ion, obviously, that I took out. If it gives away then another proton, so now if it gives away that proton, then you will sit with SO4 2-, which is a sulfate ion, plus another hydrogen ion. Okay. Then for triprotic is obviously 3 hydrogen ions. So an example like this would be phosphoric acid. So you could see that it has 3 protons, and it would want to give away each one of them. So let's start with the first protonation. If I give away 1, it will become H2PO4 minus, right? Plus the hydrogen ion. If I were to give away another one, so I'm just going to write here, if that was H2PO4 minus, if I give away another proton, it's going to become HPO4 2- plus a hydrogen ion. And if I were to give away that last one, it's going to become a phosphate ion plus another proton. Okay, alright, so we're going to now look at examples of Bronsted-Lowry acids and bases, especially something with a slight twist, and that is known as ampholytes. Now, an ampholyte is a substance that can act as an acid or it can act as a base, okay, which in essence means that it can either be, for the case of the acid, it could either be a proton donor or it could either be a proton acceptor. Okay, so let's jump into the examples and see how we can now apply the theory here. So all these substances here are examples of ampholytes. So they can either act as an acid or as a base. So for example, if I take water and I react it with a base, so if this is a base, then automatically the water is going to act as an acid, right? So according to the Bronsted-Lowry theory, your acid is going to donate a proton and your base is going to accept a proton. So what will happen is you will have ammonium forming, okay, plus a hydroxide ion. Okay, because you can see one hydrogen has been given away here, so what's remaining? OH minus. And a hydrogen ion has been taken up, so you have NH4 plus. If you now take water and let's say you react it with hydrochloric acid, this is an acid, so the water is going to act as a base, meaningly it is going to now, because it's a base, it is now going to accept a proton. Okay, so when it accepts a proton from the hydrochloric acid, so let me just show that, it's going to donate a hydrogen ion, so you will form hydronium ion, plus if the hydrochloric acid gives away the hydrogen, it only leaves a chloride ion behind. Okay, another example is hydrogen carbonate. So HCO3 minus can now react with ammonia. Okay, and I'm going to write down the examples. Okay, if you want to practice them on your own, just pause the video and try them on your own, okay, before I write down all the answers. Okay, this is also how you learn and practice by yourself. Okay, so hopefully you tried them. So now in this case, your ammonia is acting as your base, and this will act as an acid, right? So your acid gives away the proton. So what will be left behind? A carbonate ion plus ammonium. Okay, same for this one with sulfuric acid. Now your hydrogen carbonate is going to accept a proton from the acid, so it's going to become H2CO3, and your sulfuric acid gave away a proton, so it becomes HSO4 minus. Okay, that's now only assuming that your acid only gave away one proton. Right. Then another example, HSO4 minus. Okay, once again, I'll write down and then you can practice them on your own. Plus nitric acid. Okay, just pause the video, try them on your own. Okay, this is your base. This will act as an acid, so it's going to donate a proton to become SO4 minus, and you will have ammonium. Right, if you look at the nitric acid, in this case it will donate its proton, so it will become sulfuric acid plus NO3 minus, a nitrate ion. Okay, then H2PO4. Okay, if I add hydrochloric acid, what will form? And if I add ammonia, what will form? So for this example, this is your acid. It will give another proton to H2PO4 minus to become H3PO4 and a chloride ion. Okay, then in this case, your ammonia is your base, so it is going to accept a proton from here. Write down what will remain. That's a 2 minus plus ammonium. Okay, and then the last example, you can see it's now where we take this and we work with that. So HPO4 2 minus, let's say with nitric acid, and let's say with ammonia. Okay, pause the video, try this on your own. So this will act as your acid, so it's going to donate a proton, so that will grab a proton, H2PO4 3 minus, right? And that will just become a nitrate ion. So the acid gives away its proton, so this becomes H2PO4 minus, and it remains with a nitrate. And lastly, this is your base. It's going to accept a proton from your acid, so your phosphate will lose its proton, and you will have ammonia that is gaining a proton to form ammonium. Alright, so that was just a few examples. If you stick to the next video, I'm going to do a lot of examples of conjugate acid-base pairs to show you how to know when something gives away an acid, what does its conjugate pair look like. Yeah, so I hope this helped. If you have any questions or comments, please leave them. I'm willing to help you, whatever your requests are, and have a lovely day. Bye.